The focus of this video is on chords and tangent lines and how they work, or what properties pop up with circles. So the first is specifically with a diameter and a chord. So if you ever see a diameter, which would be this BG, intersecting any chord, and it creates a 90-degree angle. If that ever happens, that creates two congruent parts of a chord. Okay, so when a diameter and chord intersect and create 90-degree angles. I'm going to use another vocab word here. The chord was bisected. So that means, let me change color here.
Hello.
That means that this segment right here is congruent to this segment right here. So FE would be said to be congruent, FE would be congruent to DE, okay? And that's only if that 90-degree angle shows up. So how that might help you is, let's say you've been given this side, but maybe you have a triangle over here. You're going to be able to bring that 7 across and say that this side is also 7. Or, you know, let's say you have this side and you want to know all the way across. So you actually wanted to know AB. Well, now you know to just multiply 12.5 times 2 because there would be 2 of those, giving you a side length of, or a chord length of 25. So you can play around that idea of knowing that you have congruent segments. A second part of this idea of tangents and chords and radius, diameter, is that if you ever have a tangent line, which you can see this is tangent as it's just touching at one point, and it intersects a radius, if that ever happens, you should then know that this is a 90-degree angle. So for example, so how you would write that is, if a tangent line and a radius intersect at the point of tangency, then a 90-degree angle is created. So, and that may not be drawn for you there. You might see that you have a tangent line, and then a radius there. You would have to infer that that means that you have a 90-degree angle there. So that part is something that you would have to make a decision on. There are a lot of questions that can come out of tangent and radius intersecting. So one would be determining if it actually is a tangent line. So the question here is AB actually tangent? Well, the way we would determine that is if it was, then this is a 90-degree angle. And if that's a 90-degree angle, then Pythagorean theorem would work. So we would then go into, well, 12.6 squared plus 9.9 squared would hopefully give me 16.5 squared. And that's when we're using Desmos and figuring out if that actually works. So if we go into Desmos and we give that a try, so we have here, let's see here, 9.9 squared plus 12.6 squared, I believe, right? Is that what it was? 12.6, 9.9, and then I have 16.5 squared. And what I realize here is that those two are not the same, and I shouldn't have to round to get them to be the same. So this would be an example where this side right here does not equal this side. Therefore, AB is not a tangent line. Because if it was, it would have worked. Okay, that would have been a right triangle. So let's try again. We're trying to determine if AB here is a tangent line. So again, trying to explore if this is actually a right triangle. The tricky thing that we can see here is that this radius right here is also right here. So it looks like we don't have all 3 side lengths, but we do. This is 3.2 here. We also have to look at getting this entire length And right now it's in segments. So I would have to do 3.6 plus 3.2 to give me 6.8. Again, let's go ahead and put that into Pythagorean theorem. So is 6 squared plus 3.2 squared equal to 6.8 squared? So back to Desmos we go. So 6 squared plus 3.2 squared and 6.8 squared gives me the exact same number with decimals. So therefore, AB is tangent in this example. You can also see where I'm telling you it's tangent and you would have to use right triangles to solve it. So for example, if this line is absolutely tangent and this is our radius, this would be our right angle. And then we could use Pythagorean theorem, which I'm not going to work this all the way out, but it would look something like this and solve for c squared. Or maybe you have something a little bit complicated where they only gave you the radius, right? Well, you'd have to know that you need to then put that to here to get the full length of 4. And again, you could then set up Pythagorean theorem. In this case, we have c, so we'd have to subtract. On this one, we're just wanting this segment, right? So I could partial this out. I could find the entire hypotenuse by doing 12 squared plus 16 squared equals c squared. And once I solve that, I get c is equal to 20. And then I'd have to take away this radius right here. And I can get that from looking at another radius. So minus 12 and get that segment being 8. So there's lots of different variations that you could use to kind of solve this. Right, here's that swinging radius again. That will move me to 8.4. Oops, 8.4. So you can kind of see this question playing out in multiple ways. Last little bit of information on tangents and chords, radii. If you have two tangent lines that meet at a point, like point S, we could then say that this segment and this segment are equivalent or equal. And so... again, if you're writing this out, when two tangent intersect at a point, the segments are congruent. So we're not looking at really asking questions where you would tell me like if this is 17 and this is 17. This definitely is going to be more of an equation situation, so that you would have to set up the equation knowing that they are the same. So like in this case, x equals 7, or setting up that this segment right here is equal to this one. So therefore 6x minus 2 equals 4. Add 2. 6x equals 6. So x equals 1. All right, so after this part, you absolutely went through and were given kind of the same information, determine if the line is tangent, right? So you're using Pythagorean theorem to determine if does it work, question mark. And then in the next section, you are still using Pythagorean theorem, but you are determining missing sides here. And then last but not least, you are using the idea of tangent lines creating congruent segments. And you're doing a little algebra here. So if at any point I kind of lost you or you have questions, please don't hesitate to reach out and ask questions.